has not completed Math 32.
Have not completed Math 32.
You know, I was just treating y as an intermediate variable, and
Okay.
this really is just a glamorized version of what you had back in Math 30 for the chain rule.
Okay.
I'm differentiating with respect to, I don't know, something called out here y. But multiplying by the period of y with respect to x is sort of like my f prime of g of x times g prime of x. It's acting in exactly the same fashion. This really is just a different schematic way of representing the chain rule you had back in Math 30.
So how did you differentiate du over dx and get that?
And get this
Yeah.
By the chain rule. So from here to here is applying the chain rule.
And why didn't you differentiate the other side of the equal sign
No, wait a minute.
at the same time?
I proclaim what's between my hands right here is equivalent to this.
Okay.
They're the same. I didn't take
Oh,
action
okay.
on both sides.
Okay.
This is equivalent to that expression. This is equivalent to that expression. That's why the dy dx
Oh.
twice did not change.
Okay. Okay.
Can we also think of it as multiplying on the second step on the left-hand side by 1 over dy?
Absolutely, you can do it just as well. I agree completely. Yes. I get nervous with that because it looks just like a manipulation of fractions, but it is correct.
So it's not the same as just multiplying that by 1 by dy over dy.
Fortunately not, because
Okay.
you can't treat these as small quantities over small quantities.
Okay.
They're not fractions. This really represents a derivative of some function of y in terms of x, which, by the way, is a function I don't have, which, by the way, is a solution to the original PE.
Okay.
I really don't have it.
Why can't you treat it as a fraction? Because you can.
Oh, I'm definitely emphatic. You cannot. I think what you're thinking is this. This is equal to the limit as a change in y with respect to x, as delta x as a small quantity goes to 0. That may be true, but this is really referring to the derivative of unknown function. There's no fraction of small quantities here. At least not the way I've got it written, that equation over there.
Your small quantity is change in y.
I disagree completely. You're thinking of differentials. And I think with differentials, we sometimes write dy over dx as differentials, but since I started off with a differential equation, dy dx is representing f prime of x.
But isn't dy still the differential one? Is it not?
100% no. So I think when you look at dy dx notation as notation for derivatives, it's completely different than looking at differentials, because your differentials are small quantities. And that's why I'm always upset with differential notation. It's ambiguous. But I think in context, you know my dy dx is referring to a derivative because I'm trying to solve it. So in context, it's understood what my dy dx represents. Okay, everybody, I failed to apply this u sub. I didn't finish rewriting the first equation, or the original equation, so let me rewrite. Is that a plus 1 over y? Is that a u squared? And is that equal to a y times e to the negative y u cubed? I don't know. What kind of DE do you think that is? I think it's clearly Bernoulli. If I divide by u cubed,
I hear cannoli.
I think I get this. Excuse me. Oh, jeepers. You guys, that just screams out all we're going to do is...
You can't. It's not in that.
I could examine 2 days. Let z equal u to the negative 1. I like them. So now I can transform with this Bernoulli sub. I can transform this dE into first order linear. And committing to this, I think this necessarily implies that dz dy is equal to negative u to the negative 2 du dy. Having said that, committing to this new substitution, I think another name for the very first term is merely a negative dz dy. I think another name for the second term is merely a 1 over yz. And it's equal to whatever this function, this forcing function is over here. I used the phrase forcing function. I take that back. I've not used that phrase yet. And since this is first order linear, you know what I'm gonna do next. I'm gonna find an integrating factor. And I think the integrating factor in terms of y is simply gonna be of,
First you have to divide by -1.
thank you, I didn't do that. I apologize, I completely missed it. I'm trying to beat the clock. That's a big deal, though. That'll change the integrating factor dramatically. Let me say that again. I think the integrating factor, which by the way is a function solely in terms of y, is merely going to be, I don't know, I gotta look. Is that a 1 over y?
I mean, e to the integral of,
Yes,
Yes.
he just did it all in his head.
yes.
So this is correct, though, right?
Yeah.
And in multiplying both sides by that integrating factor, the left-hand side would be the result of differentiating with respect to the variable y, the product of this maybe embedded 2 or 3 times longer substitution of this dependent variable times my integrating factor being equal to the right-hand side if I multiply by the integrating factor. Oh shoot, that turns my life into such an easy life. And undoing the differentiation process. Isolating z. What's next? Back substitution, maybe a few times. Well, one at a time. Jesus. But that gives me this. What's next?
Back substitute for you.
Back substitute one more time. I think you originally had this name right here. I think dy dx. What's next?
Separate variables.
Separation of variables technique. I will integrate this beast. And I will likewise integrate this beast.
So, at this point, have we learned how to solve any integral, or are there still plenty of integrals that
We have learned, we have not learned how to solve most integrals.
most integrals? Will we by the end of this class?
Heck no. And besides, you've been limited to Riemannian integration. There are different types of integration.
So, at your level in math, are you able to solve all integrals?
No.
Or are there just still plenty
No,
that
for
are
any
just
mathematician,
unsolvable?
most integrals outside that door are non-integral.
Okay.
And you guys, integration by parts. Does that give me a negative y e to the negative 1? I'm starting so slow. Is it a minus e to the negative 1? I'm pretty sure.
Yes.
Yeah, it works. Plus C1y, I meant C2y squared, plus C3 is equal to x. I promise you, you're not able to solve for y equal to x. Wow, you guys, you did a lot. I'm nervous. I really don't want to come in tomorrow and discuss differential equations. I missed one section. Because it's disjoint anyway, can I slip it at the end with power series? So that I can start tomorrow, chapter 2.
Okay.
Okay. However, for tonight,
Doing power series at the end of the...
yeah.
That's one I was excited about.
1.9. 15 odd. In addition, take a peek at 21 through 25 all. We haven't done a lot today. Section 1.11. How about one? Here, 15 on. Unless they're difficult, just do the evens as well.
And so, everything through 1.11 we can expect to be on the exam? Just trying to space out my homework,
Yeah.
so,
I'd say so.
yes.
1 point.
So in other words, the exam covers all of chapter 11 except for 110. And I should say 112, but it covers.
Chapter what?
What's that?
You said chapter 11?
Just a bunch of ones. All of chapter 1 except for section 1.10. And 1.12 is just chapter review.
Okay. Oh,
So 1.11 is not going to be on the exam?
All of chapter 1.
digging up
Which
old,
includes 11.
Oh. yeah.
digging up old DE examples. Would you still have time to do that?
I'll squeeze it in. I've got a rush.
Okay.